Okay, so hi, good afternoon. We are from Group 13. So today we will present our project, which is a title. Our project title is Prediction Rain using machine learning. Okay, for the objective of our project, the first one is enhancing rainfall prediction accuracy. So that the traditional weather forecasting models can be limited in precision. Second one is addressing class imbalance in rainfall data. So why we do that? Because the rainfall data sets are often imbalanced with a fewer rainy days than non-rainy days. The third one is comparing machine learning models for weather prediction. So this project allows us to compare different models to find the best performing approach for our project. So we move to our motivation of project. The first one, we understanding weather patterns, improving forecasting accuracy, machine learning in meteorology, handling machine data, and informing decision making. Next.
For the literature review, we compared four papers. The first paper, it compares logistic regression, decision tree, and random forest and SVM, and it identifies that random forest as the best performing model. The second one, it evaluates traditional machine learning and deep learning models, which are LSTM and ANN. Based on this, LSTM outperform traditional models in long-term rainfall prediction. The third paper, it focuses on time series forecasting for rainfall prediction, and it uses four classifiers, which are gradient boosting, XGBoost, and ALSTM models, and it finds that XGBoost are the best performer. The last paper, it implements ensemble learning, which is a combination of random forest, gradient boosting, and KNN to enhance prediction accuracy. And it demonstrates that combining multiple models improves overall performance. Next. So for our framework, we started by dataset collection, and then we did data processing, which are EDA, normalize feature and extraction, cleaning the data. Next is data balancing, which includes undersampling, smooth oversampling, and no resampling. The next one, we did model reselection for logistic regression, decision tree, random forest, KNN, and gradient boosting. And next, we did splitting validation into two parts, which are model training and model testing. For model testing, we did 80%, and model testing, we did 20%. Lastly, we did performance evaluation, which includes accuracy, precision, recall, F1 score, ROC, AUC, and PR AUC. Next.
Okay, for the data set, this data set contains daily weather record from various locations in Australia with 145 and 4600 instance and 22 attributes. It is include key meteorological features such as temperature, humidity, wind speed, atmospheric pressure, and cloud cover used to predict whether it will rain the next day. Okay, so for the next one is this data set is useful for weather forecasting, climate analysis, and decision making in agriculture and disaster making. So the column rain tomorrow is a target variable, which is they are helping machine learning models predict the likelihood of rainfall based on the condition.
Going to the data preprocessing, I will be mentioned four important things that we did here. First, which is handle missing value. We check how much missing data there is in the data set by calculating the percentage of missing value in each column. We fill in the missing value in categorical feature using the mode and use multiple imputation by chain equation to replace missing data with estimated value. Second, we remove the outlier, which is we use box plot, make it easier to detect outlier for better readability. To address outlier, we introduce the tree function that utilize the interquartile range IQR method. This first outlier threshold, check the outlier and replace with threshold. Values lower than lower bound are replaced with the lower bound, and the upper bounds are replaced with the upper bound. By either replacing them with a specific threshold value or with the median of the column. Third, we will be handle the multi-collinearity problem, which we calculate the correlation matrix and then visualize it as a heat map to show the strength of the relationship between features. As we can observe, there are some features are highly correlated. So we adopt the VIF method or covariance inflation factor. In this method, we pick each feature and regress it against all of the other features. After we calculate it, we select the variable with the highest VIF value and we remove it. so that it produce an important decrease. And fourth, we check the imbalance data set for the target variable rain tomorrow between two categories, which is yes or no. As you can see, the majority is no, and we will be implement this mode in the next session. Okay, that's all from me.
Okay, hi sir. My name is Veena. I'm going to present about our raining prediction models. We are testing on the resampling the techniques of not resampling and also more and undersampling, which are the five machine learning models and linear regression and recent tree, random forest and k nearest neighborhood and gradient boosting. To evaluate the performance, we are using a key metrics, accuracy of the overall correctness and recoil for the detection positive cases and precision to reduce the false precipitation and F1 score to balance the precision of the recoil and precise recoil under area under the curve PRURC to differentiate the between the positive and negative classes. And the results and discussion, we analyze the model performance across the different reasonable techniques, and these are the results that we get so far. And gradient boosting and no sampling is the best accuracy for F1 score and PRUR and ROCUR. And random forest is not resampling is highest precision of the 81%.15, and gradient boosting is undersampling has best recoil 86.868, which makes the ideal for the detection of the rate. This method are useful to duplicate whether the prediction of overall performance is reduce the false alarms or maximize the detection. So the result of the conclusion of recommended is gradient boosting is not resampling is overall model. So these the model we are using to our project for this raining project prediction project, and the random forest not resampling is best, but it's we can use that kind of model to reduce the false positive cases only. And other than that, gradient boosting undersample is ideal maximum the rain detection only. So the final option is our application is using is gradient boosting is not resampling. So for the developing, we are use a flash web application. We build a flash web application where the user can enter the location and date to predict the raining. This is the example. So when I enter the location and the date, I get the output, which is yes, it's raining. And second, I try to give another output. I get the prediction. No, it's won't rain. So this is the example model we are designed to for our project.